NIC, Nick. Nick and then some numbers.
So maybe this is even different person. So
yeah. But what it does is you flash that ROM, and you've got the SerialICE itself. The ROM part, it runs on a key config kind of system. It's not core boot itself, but has a core boot like directory system. Minich, you may know the guy. He's pretty big in this area. He was working on boot for the AMD machines, but not anymore. Yeah, exactly. It's pretty cool. I'll tell you about that in a little bit more, Al. He was working on some Rome machine, and he had wrote a patch that integrates SerialICE into core boot itself, and that's what I'm using currently. But it wasn't accepted into upstream core boot. But it's a very easy patch to slip into any project just to use it, even if it's not really part of core boot per se. So, yeah. So what it does is it runs the normal vendor BIOS from, in the QEMU side, and it logs all attempts at modifying hardware registers, IO, memory, MMIO, whatever. And then if it tries to do that, it sends it down a serial port to that special ROM, and that ROM will, fiddle the hardware bits to make it do whatever the QEMU side is doing. And, that's really useful because, you can just basically log everything that the hardware is trying to have done to it. But it's also a little bit arcane because, if you go down the first bit, there's a lot of stuff that's right. You'll see a lot of in-B and out-B, and if you don't know the IO ports and stuff, that will make no sense. I currently have in this demo some parts of the decoding disabled because it clobbers something that I worked on. But it was letting me see, hey, it's probing this register. Oh, hey, this is how they keep the computer from turning itself off because this is a quote unquote gaming desktop and it's got RGB. And it turns out if you don't initialize the RGB controller on this thing properly, it reboots the whole system in 10, 15 seconds every time. That was a fun figure out.
This is very fun figure. I know that you don't have time for write up about that, but this is crazy. This is this madness.
it honestly is because I got the board view. I can share my screen and show you, but let me see. Window, open board view, share. Yeah.
Yeah, quality is not that crazy.
This little guy right here is an 8051, I think they call it, from Nuvoton. And it's got some firmware on it.
8051 is like a general, very old chip that everyone implements their own.
But it's hooked up to the reset lines and such, so it can turn off the computer. So you got the power off. Let's see which one of these is it. Yeah. Okay, it's not taking a direct line. Yeah.
Shall I ask how you get that one, or I should not ask that?
I mean, this one, friend on IRC pointed me at a Indian laptop fixing forum.
Okay.
You know the ones.
Yeah.
It cost me $5, so who cares?
Yeah, paywall $5. Yep, I know that one.
You know the ones.
Yep.
But and that's how I figured it out because Green here on Dasharo, the normal place, not Jitsi, he sent me his old LA 2016 logic analyzer, and that's how I was able actually to figure out why the machine was shutting off because I realized that this was hooked up to both the I2C bus and the power line. So I'm like, well, let's just log it, log the I2C bus when it's powering up with the normal firmware. And, I snatched the packets and it's 4 bytes. And then now the computer doesn't turn off anymore. Yay. And now I can actually make progress. It is handy though. Cause I know where I can tap in and get some signals and things of that nature.
But on the other side, anyone had idea why this weird why this weird kind of situation where RGB controller kind of blocks booting or
Poor design.
Yeah, I mean, like, I have absolutely no
poor.
idea.
This is like where this is like gentle words. Like this is like
Yeah, I have no idea why they would.
It actually could be used like a vulnerability, like hooking up like some stuff that, for example, like shorts up your RGB outputs, and for example, I don't know, burns your chip literally and like disables your booting process. Like that would be fun.
It would be horrific. So before I got our Minich's core boot SerialICE patch thing going, what I actually was doing was I actually took a Raspberry Pi Pico and wrote a tiny little firmware for it that all it does is spit out the I2C things that it's expecting. So I would turn on the computer with SerialICE, and because it wasn't able to initialize the hardware itself and prevent itself from turning off, I would just plug and unplug that Raspberry Pi Pico a couple times and hope it didn't turn off. And if it didn't turn off, then I'd go on with myself.
Mm-hmm. So Hannes, like if I recall correctly, like professionally, you're not doing this. Like you are not.
Oh no, I'm just a guy.
But you know, with that knowledge, like with this kind of level, like we can easily apply for, you know, for some position if you care about that. If you don't want to destroy your hobby.
There is that, and honestly, my working and living situations is a little bit weird, and I don't want to get into it here, but I'm kind of happy with where I am, honestly.
Sure. I'm just saying, because you're doing this, like, if you're doing this for so long time, you essentially trained. You are like, I'm amazed, because like when we talk, I guess like last quarter or even either, it was like, maybe this, maybe that, maybe this board, maybe that board, and right now like you are essentially like moving forward with so weird stuff, so cool stuff that it's worth, you know, listening and worth talking about.
Oh yeah,
and definitely good knowledge, like very good experience.
It's very fun, if nothing else.
Okay,
but you know, SerialICE has if y'all know SigRock, it's kind of like protocol decoders, I guess you could say.
Yeah.
Because SerialICE, when it logs in the rawest form. So just, you know, out B, in B, write mem, write L, read L, you know, just as raw as possible. Read CPU ID, read MSR, whatever. It doesn't actually tell you what it is. So you write filters in Lua, which I do not speak natively, to decode that out. But now they provide you with a large number of, you know, how do you say, pre-written ones that are pretty generic, you know, like Super IO based stuff, messing around with PCI config space via the CF8 register, I think. Whatever. You know what I'm talking about. So I had to figure out a few things, because yeah, but does it speak the specific subset of Lua that SerialICE uses?
I don't know. Like, but you know, like you always can try accelerate. Of course, like it depends if this will cost more time to explain it, what you want to do, or it's just it depends what you try to do. What was your task? What was your goal? And if it was easier by just like trying to feed it with that information, feed the AI, or look the forums, look the Stack Overflow, or just like have good support from someone who knows that already. Yeah.
Yeah, I mean, like I get how Lua works. Is a little weird because, you know, it's a programming language. I mean, it starts counting at 1. What's up with that? That's weird. But
that's LaTeX stuff.
Yeah, that's weird. But you know, I knew what I wanted to do. I just needed to learn the vocabulary and grammar to say it in Lua. And the reason why I had to write another filter, aside from the other ones, is one, SerialICE, as it currently stands, is currently heavily teched out to Intel stuff. It doesn't really have much AMD specific support, let alone Ryzen specific support. So, like, I could see a lot of MMIO operations that look like they're probably messing with the data fabric and things of that nature. because like, you know, turn a PCI BDF into MIO address and it's the right spot. So I guess that's what it is.
Yeah, I
And-
guess like what my question would be at this point is like, what does it mean? SerialICE knows better Intel. So is there a easy way to tell SerialICE to recognize certain pattern of, I don't know, MMIO, to know how to name it, or like how this help you? How SerialICE knows about that, and how this help?
Well, like I said, you write, they call them filters. They're basically protocol decoders. And when you run the replaying software, because it comes with the replayer so that you can, you know, play back and look at, adjust the filters, play back, look at, whatever. It comes with that. And how do you say? It comes with that. And the first thing it does is it at the very beginning of the process, it records a little bit of information about the hardware that you use to record. So, you know, the make, model, yada, yada. And from that, it can determine which Lua files it needs to load. It'll try to find a Lua file in the mainboard's dir, load that, evaluate it, and use that on top of all the standard filters. SerialICE comes
but
with...
how this Lua filter help? Like, does it like replace something and make it human readable, or like what?
It does that, and also sometimes you really do not want certain hardware operations going from the QEMU instance to the real hardware. Like that was an issue I had early on. Was the firmware itself in QEMU was attempting to configure the serial port, but the communication between the hardware and the emulated ROM is over the serial port. So if you fiddle with the serial port, the link dies. So that's one thing you can do with the filters. You can explicitly filter things. Like, I really do not want you to actually send this byte to the Super IO and turn on this thing, because that will destroy the whole process. So you fake actions, you modify actions.
Because essentially you will... Yeah, I understand, because essentially you will have to have real hardware, real controller, which respond with some register status to that action, and you don't have that, so essentially you will very quickly stop the booting process, But but continuing this, like faking this, like essentially this filter like fakes the situation, like help in faking that you are not, that you are on real hardware, Like,
well,
but you are not on real hardware,
It's the ROM is executing in the QEMU, but it is forwarding all unhandled IO and all IO that is allowed to be to the actual hardware. So if you don't have a filter for something, everything that is happening on that something goes to the real hardware. It's only with a filter that you can discriminate and choose that, okay, I'm okay with this going to the real hardware. Because I know it won't break the setup. It won't, you know, halt, catch fire on me. Also with filters, you could do useful things like you can lie to the firmware and tell the firmware, oh, this is only a single core, single thread SCUS. Don't even bother trying to wake up those other ones, guys, because that might confuse things, you know? So
yeah.
I think I might be having an issue with relation to that, but I don't know yet, because like right now, my chief difficulty is that SerialICE works for the most part, and it configures a lot of things. I see it happening, but then it gets to a certain point where it gets in a polling loop, and I got to figure out how to get around that somehow. But yeah, the way it knows which filter to load is...
Let's try to wrap up how this whole process help in kind of open source firmware development.
Well, in this case, and probably in Intel as well, but I don't have an Intel machine. I can run SerialICE on the offhand. You can run it with modified firmware, right? And that was one of the first things that I tinkered with on this machine. Is I was disassembling, and if you go in the ASCII cast to 618 time, you'll notice a very large wall of text.
Okay.
And one of the first things that I was trying with this thing is I was disassembling the firmware, into its PEI and DXE modules and such, and then loading them up in Ghidra and hurting my brain a bit. But I noticed there was a lot of printf-looking strings in it. And what I ended up doing with that is I, dug down into it. And it turns out all those is a search for a particular PPI, which is a protocol in UEFI. And, it has a GUID. And if it finds it, it calls a function from it. And I'm like, well, why can't I do that? So I hacked together.
This is.
Go ahead.
This is exactly PPI is a PAIM to PAIM interface.
Yeah.
So it's like a PEI stage
exactly.
before Dixie. This is like protocols, because protocols are for Dixie, and PEI got PEI module to PEI module interface. So this is how the PEI modules talk with each other.
Right. I mean, like, I might not know the exact terminology properly, but thankfully, because the way UEFI is put together, the binaries are very structured, and you can usually spot some data structures and figure them out. And there's a couple of projects that are really nice on that. But I hacked together a very small PEI module that implements that PPI, that PAIM, that PPI, whatever. And I inserted it into the firmware, and I flashed it on real hardware, and it worked. And it turns out, like I said, if you go to 618 or so, I could do this on SerialICE as well, and I could get all this debug information out of it.
Like, just a second. What doesn't mean you hacked? Like, what precisely you did?
I took the UUID that I was given, and I wrote a PEI module that uses that UUID, that GUID, and fiddled around until I got it to work. And then I used UEFI tool. You may be aware of it.
Yeah.
To insert the module into it, and then I modified the a priori pi file, which is like a load me first.
That's crazy. That's crazy like shit. So you essentially wrote a PEI module. So PIM, PAIM to PAIM, PPI are protocols where PEI modules talk with each other. So you write PEI module. How you write it? Like, did you take like sample PEI module from UEFI if you're EDK2 and just like write it and compile it, or how you did it?
I was looking at the source level debugging package.
Oh yeah.
And I was going to see about getting that to work, but then like I said, I was digging around and I found that particular thing. I'm like, that might be really useful. Let me try to make that work. So I followed a lot of I bodged together a lot of code that was in that particular module.
So how much time it took? Like, how much time it took to?
That was at least 2 weeks of fiddling.
Okay. Like total hours? Like, it's like I guess like you're doing this after hours, or how this works?
I usually go real hard on this stuff, like maybe like for 2 hours a day.
Okay.
Because like there's a lot of issues involved, because like the PEI phase is really, really sensitive, and like because of the fact that the initial code load on this particular Ryzen board is, I've only got 3 megabytes of space and it was already jam packed. I had to, I was using SerialICE a little bit at that time. And if you look in the column between the brackets, those, the second one, FF, whatever, that maps basically directly to the address on the flash chip itself. So I was able to figure out what modules were actually being used, which ones were not being used, and actually excised a few modules to make room.
Okay.
And yada, yada.
Yeah.
But yeah, that was that. And like I said, apparently it works in SerialICE itself, which is great.
Okay, but so you managed to do that. Like, this is great achievement, but still, the question is like, how this make us closer to open source firmware?
Oh, well, somewhere else in this particular video, but it has a section where it spits out what in how do you call it in Ryzen and core boot terminology they call port descriptors. Now, it doesn't help me yet because apparently there's something going on here that I need to fiddle with more. But in theory, if you can pull out the port descriptors in that manner, you should be able to use it on porting your new one, because like it tells you like, you know, oh, we're going to turn on this GPIO. It gives us a lot of debug information. And I don't know that every AMD Ryzen firmware or hardware or any of it is going to have this kind of information available even with this kind of a modification. But for the ones that are able to accept a modification of this variety and it'll work and you can pull this information out, you can use as a starting point for putting together the board port, you know? And I still have issues going through with that, but right now the only thing that's really holding me back is these platform descriptors, because like I can actually boot core boot. It runs through FSPM, FSPS. I had to modify the SFP, the memory blob a little bit to make it work, but that's besides the point. And it'll load a payload, and it'll even try to boot Linux. But after that, I'm kind of kerfuffled.
But like, is it problem of Linux? Is it problem of initialization of the system?
I'm not sure, honestly, because the builds they give you, they do not talk. The FSP builds that you get from whatever it is, it doesn't talk. That right there is. Oh, hang on. Yeah, there we go. There we go.
So I guess like we should try also to address void concern. What is this hardware detection tool? You were able to run hardware detection tool?
Yeah, it's got. I was like I said, a lot of interesting. I could try that.
So this is on real hardware. This is core boot on real hardware.
The second one is real hardware. Yes, that is absolutely real hardware.
That's very good. That's congratulations. Like that's incredible achievement. Like damn, and it's on Ryzen 3200. Yeah.
Yeah, 3200 on that ASRock board.
Is this code already somewhere in?
Oh yeah. Give me one sec. I got it on my GitHub, and it is on the Garrett, but I ain't getting any action yet. But I've been talking with people about things.
So I guess like we should like try to wrap up. But I guess like there is a lot of question, and I'm like mostly concerned about void disconnection. So I guess like we should address that, and then we can go. We can try to get back on track with like where's core boot on all this, and so void like I'm trying to understand like how we can help you to understand what's going on here, because I see that Hypnotic tried to explain. It's okay. I don't need to. Okay, that's fine. Okay.
If you ever want to talk void, we could talk anytime.
So he's got problems with this audio stuff. And
yeah, I remember. You thought he was over Tor.
Yeah. But
I thought he was over Tor.
Oh, I'm sorry.
Anyway,
no.
He mentioned that earlier. But anyway, so Haneter, like, so how's things with core boot? Like, so what's the major like blocker? Are you saying this Linux not booting or something?
Well, I'm not sure if it's a killer, because this Linux is booting off of a USB stick. As far as hardware that works on this thing right now, that I know to work, there's a few USB ports that work, and and theoretically maybe hang on. There's a few USB ports that work. Obviously, the serial port works because that's bog standard. And if your serial port doesn't work, what the hell are you doing? But I boot it from the USB. I've tried it with both an installable, an ISO on USB type thing, or also with the an actually installed system. Neither of them actually work. So I'm not really sure here what is failing.
So it's like a malfunction of the of the initialization of the USB controller?
I don't know, honestly, but I think it might have to do with those platform descriptors or port descriptors, because right now my major issue is like if I send any port descriptors from core boot into the FSPS binary,
Mhm.
the whole thing halts.
Hmm.
And it doesn't give me any feedback when it does.
Mm.
So that's the big thing, because if you don't know the platform descriptors, they're just basically saying, hey, I've got a 8x PCIe port here. Oh, hey, I got a SATA controller here. You know, a lot of the really important things need a platform descriptor to work. And then, you know, there's a few ports and things of that nature that are underneath the
Why
the
you cannot
X3.
catch it? Like why you cannot catch this as exactly this piece from the serial IC?
Well, that's why I was saying it catches itself in a loop. And I did catch that information. If you watch it through, you'll see a section where it says sending this platform descriptor to the to the SMN or the SMU. I forget exactly what it says, but you'll see it say that, and then it'll show you a hex dump of the platform descriptor, and before that, it gives you a little description that's it tells you what's going on.
And did you try to send the same?
I did, and like I said, if I send anything, it doesn't work.
Okay. So maybe
So
there
I
is
think
some
might be
previous action that makes this possible, even. Yeah.
Yeah, I mean, like I've been digging around in the FSPs modules, because the FSPs they're UEFI file systems too, so they've got the same structure, they've got the same abilities to be, to figure it out from that. But it's frustrating, but it's fun. No, actually, they are not encrypted at all. They are just plain old, binaries inside of FFS.
Yeah, with probably with header saying do not reverse that.
Yeah, I don't give a shit.
That's fine, but
that's probably one reason why I'd probably never go into this as a for a profession, because then things.
Yeah, legal.
Yeah, but I'm just a person. What are you gonna do? Yeah,
true. Unless you will make money, like huge money on that, that's then they will pay for you.
Right. We'll see.
So you plan to make money on that?
Hey, you never know. I don't know what is gonna. I mean, like it would be nice. I'm not gonna turn down a grant or anything of that nature. But like I'm not doing it for the money. It would just be nice sometimes.
Sure.
Well, yeah. I mean, Void. Yes and no. I mean, like the FSP, it's just x86 code, and Ghidra handles that lovely. And there are a number of Ghidra extensions that are specifically tailored for working with EFI-based binaries. So when you use those extensions, it knows certain kinds of EFI types. It knows what a GUID is. It knows what a PPI is. And it can find some of those. Some of them you just got to have a little bit of a intuition and looking at it for a while. Because like now, I just spot the shit. Because like there's like certain structures that, like we were talking about the PPIs. The PPI is a certain magic set of magic numbers and bit fields basically. Then it's a pointer to a GUID. Then it's a pointer to a function usually. Sometimes it's just a pointer to data. Once you know what you're looking for, it's there. And like I said, it's very structured. I have no idea about machine learning, bro. I know it makes funny pictures. But yeah, I mean, like that really about covers it up. But like, even once I get this particular issue figured out, as far as like getting the PCI stuff running and maybe figuring out how to make the USB boot, I was thinking about maybe trying a Linux boot payload, because then it would like take another element of confusion out of it. Because like I'd like to get some kind of shell into the system under my firmware so I know what's going on, But aside from that, there's another difficulty, but I think that's not going to be as hard as one might expect. Is that the chipset on these devices? They also use firmware. But it turns out that a friend of mine, Cyrozap, I think I'm saying that right, he's working on an ASMedia reverse engineering project, and it turns out the firmware that these things load into the chipset is exactly the same format and file, yada yada. And the Asahi Linux folks, they figured out how to load those properly, so we could probably just, crib that code from them once we get to that point. But anyway, that's about it for me, I guess.
Yeah, I guess I love it. Like I love it. This is like great. This is like great testimony. Like.
Yes, that is an open source bunker void.
So the church of open source firmware needs testimonials, and your testimonial was really great. And what I can say, like this story is, you should have a write up. I know that you probably.
I'm working on one, but like, I'm not a writer. I'm not a talker. I just like to tinker, bro.
Yeah, I understand. Like this is authentic. Like I understand that. It's hard. It's probably very hard, but I'm just saying you what will bring like a lot of value to the world. Yeah, and write up about this would bring a lot of value to the world, definitely. On the other side, the problem is, I guess, to someone follow your path and essentially, because like you just I guess talk with various people, get the advices, and do this travel, do this like journey of going from this to that, from that to that, from that to that, and that journey is, and the fact that you were so kind of, I don't want to say stubborn or I don't know, like it so much, the experience that you get through that is very exciting. But on the other side, the question is like, if there will be another person, and I'm pretty sure there are many other people who may even step on that journey, on that path, on that road, and they didn't get through because they were not so convinced, or maybe they hit the wall at some point, and you already solved some problem, which help move one step further.
Yeah. I mean, like, there are a lot, like I said, the RGB controller killing the thing. That's
yeah. You never know what killing what's going on with it.
That boggled my mind when it was figured out.
Yeah. So that's really great. I'm wondering where this will go, and I'm very happy, Hanetzer, you are part of Dasharo community, because like we also need people that saying plainly, like, I don't want to deal with that professionally. I just have fun, and that's good for me. I like at some point, this is maybe a little bit going into philosophical discussion, but I made that switch, and sometimes I have feeling of regret. Yeah, there was so much fun. And now there is like, you are forced to do this and that and that and that.
Mm-hmm.
But on the other side, the question is, why you're doing these things? And I guess like your motivation aligns with what I think with my motivation also. Like, my motivation is aligned with your motivation at least a little bit, because you're looking for this transparency for what's going on behind the scene and why. And loving discovering how computers work, and that's exactly what 3MDEP and Dasharo is about. Yeah.
Yep.
Yeah. So
it's been a fun one, that's for sure.
Yeah. So thank you very much for that. And I guess like if there are any questions regarding the SerialICE or
let me go ahead and share also the repo that I have that shows the SerialICE stuff that I threw together to make this work.
Mm-hmm.
Hang on.
So please note that the Jitsi chat is not persistent. So whatever you put there is like it's better to send to Matrix. Like Matrix will
Right.
will
Yeah,
keep
put
the
it in the
information.
general.
Yeah. I'm doing it.